So in this video, we are going to continue with our chapter number 8, Introduction to Trigonometry, exercise 8.1. We are going to look into question number 3. Let's read the question. If sine A is equal to 3 by 4, calculate cos A and tan A. So we are given the value of sine A and we have to find the value of cos A and tan A. So we all know what is the definition of sine A. So let me just quickly write it down. Sine A, sine of angle A is equal to opposite side of angle A, the whole divided by hypotenuse. Okay, this is the standard definition of the trigonometric ratio sine of A. Now let's apply it to a triangle. So I'm going to draw a right angle triangle here. Okay, so this is my right angle triangle here. This is my right angle triangle. Now we are given sine of A. So let's assume this is A, this is B, and this is C. Okay, now for this angle A, let me highlight it. This is the angle A on focus. Okay, now for this angle A, opposite side of angle A is going to be BC and AC is the hypotenuse. Hypotenuse is always the side opposite to the right angle triangle. So we are going to substitute this given value in this equation. So let's do it. So I'm going to get what is sine of A, that is equal to 3 by 4. Okay, and that is equal to what is opposite side of angle A, this one, BC. So let's write it down, BC divided by what is the hypotenuse. The hypotenuse is AC, so I'm going to put here AC. Okay, so now let's assume for the sake of understanding, let me draw a line here. Okay, so let BC be equal to 3k. Okay, where k is some common factor, and AC be equal to 4k. Okay, we can say this because BC by AC is equal to 3 by 4. So let the length of side BC be equal to 3k and length of side AC be equal to 4k. So I'm going to substitute these values here. Okay, so let BC be equal to 3k and let AC be equal to 4k. Okay, now using the Pythagoras theorem, let's come to this side. Now using the Pythagoras theorem, we are going to find the value of AB using Pythagoras theorem. Okay, we have AC square as equal to AB square plus BC square. Okay, but what is AC? AC is equal to 4k the whole square, and that is equal to AB is given as 3k the whole square, that is equal to plus BC square. And therefore I'm going to rearrange. BC square is actually equal to 4k the whole square minus 3k the whole square, and that is equal to 16k square minus 9k square, and that is equal to 16 minus 9 is equal to 7k square. This is our BC square, and therefore BC is equal to under root of 7k. Okay, square root of 7 is under root of 7 and square root of k square is k. So BC is equal to under root of 7k. So I'm going to make a note of that point here. So oh, I think I made a mistake. Okay, hold on. BC was already known to us. We wanted to find AB. Oh, okay. So okay, let's quickly rectify this. So BC was 3k. So 3k was BC, but I messed it up. No problem. What we are going to do is, let me erase. So let this be BC and let this be AB. AB. This is going to be AB. AB, AB, AB. Okay. So AC square is equal to BC square plus AB square. So this is AB square. This is AB square. This is also AB square. So AB is equal to under root of 7k. Okay, cool. So let me make a note of here. AB is under root of 7k. So thus, now in this given triangle, we have found out that we know all the four sides of this triangle. Now we have to find cos A and tan A. which is quite a straightforward thing to do. Now what I'm going to do is I'm going to just bring this down, copy, and paste. Okay, great. Now we have to find cos A and tan A. So let's zoom in. Great. Now what is cos of A? So cos of A. Cos of A by definition we know it is equal to adjacent side of angle A, the whole divided by hypotenuse. Okay, this is the definition of cos of A. Now what is the side adjacent to angle A? It's AB, and the hypotenuse is AC. But what is AB? AB is under root 7k, the whole divided by AC is 4k, and that is equal to under root of 7 divided by 4. So this is our value of cos of A. So this was our cos of A. So cos of A is equal to under root 7 by 4. Next we have to find tan of A. So let's continue. Do the different color. Now tan of A is equal to opposite side of angle A, the whole divided by adjacent side, okay, adjacent side of angle A. Now that is equal to, again, what is the side opposite to A? Is BC, and adjacent is AB. So let's substitute that, BC divided by AB. But what is BC? BC is 3k, and what is AC? It's under root of 7k, and that is equal to 3 by under root of 7. Okay, so this becomes our tan of A. So thus we have found out cos of A and tan of A, which was what the question had asked. So this was question number 3 from exercise 8.1. Now let's go to the next question, which is question number 4, same from exercise 8.1. It reads, given 15 cot A is equal to 8, find sine of A and sec of A. So kind of similar to the previous problem where we are given one trigonometric ratio for a triangle and we have to find the other two. So let's first note down what is given to us. So the given information is 15 cot of A is equal to 8. So I'm just going to rearrange. So cot of A is actually equal to 8 by 15. However, what is cot of A? Cot of A is equal to, by definition, it is equal to, yes, it is actually equal to 1 of tan A. So if you don't remember the actual definition of cot A, you can go with the derived definition, because cot A is a derived trigonometric ratio. It is not a standard trigonometric ratio. So that is equal to 1 upon tan A. 1 upon tan A is nothing but cos A upon sin A, and cos and sin are the standard trigonometric ratios. So we know their definitions. Okay, so cos A is nothing but adjacent side to angle A, and that will be whole divided by opposite side to angle A. Okay, so this becomes our, now this becomes our actual understanding of a triangle. Okay, now we are going to focus on these two parameters. Okay, let me in fact mark it down. We are going to focus on these two. Okay, these two parameters we are going to focus on. Yes, 8 by 15 and adjacent to angle A and opposite side to angle A. So now what I'm going to do is, let's draw a triangle. Okay, let's draw a right angle triangle. Yes, and let's zoom in. Yes. So let this be our angle A. So this is our angle A. Let this be B. Let this be C. So now, now this is the angle on our focus, angle A. Now what is the adjacent side to angle A? Adjacent side to angle A is AB. So let me in fact make a note here. So cot of A is going to be equal to adjacent side to angle A. Adjacent side to angle A is AB. So AB, the whole divided by opposite side to angle A. So opposite to angle A is BC. So that's going to be equal to BC, and that is equal to 8 by 15. So this is in fact my given. Now since AB and BC are ratios to each other, they are in a ratio form. So let's assume there is a common factor K between them. Okay, let K be a common factor. Okay, therefore we can say AB is equal to 8K and BC is equal to 15K. So this becomes the length of the sides of a triangle. So I'm going to make a note here. In fact, AB is equal to 8K and BC is equal to 15K. So this becomes our sides of triangle. Now let's focus on the question. In the question, we are asked to find sine A and sec of A. So clearly we are going to need the length of this hypotenuse. So let's go and find the length of the hypotenuse using the Pythagoras theorem. Remember, this is the right angle triangle. So the side which is opposite to the right angle triangle is the hypotenuse. Okay. Now let's quickly use the Pythagoras theorem. Oops. Okay. So now using Pythagoras theorem for this triangle, using Pythagoras theorem, okay, we have AC square as equal to AB square plus BC square. That is equal to, what is AB? AB is equal to 8K the whole square, that is plus BC is equal to 15K the whole square. Now that is equal to, let's come down, okay, that is equal to 64K square plus 225K square, and that is equal to, if you do the addition, 5 plus 4 is 9, 2 and 6 is 8, and this 2 as it is, so 289K square. That is our AC square, and therefore AC is nothing but under root of 289K square, and that is equal to square root of 289. 289 is a perfect square, so its square root is going to be 17, so it's 17K. Thus the value of AC is equal to 17K. Now I'm going to make a note of that here. So AC is 17K. Okay. Now thus we have this triangle ABC where all the three sides are known to us. If you know the length of all the three sides, you can find any trigonometric ratio value. Okay. So what I'm going to do is, we are going to make a copy of this and take it to the other side. Copy. Oh, we don't have other side. Okay. Yes, there is other side here. Paste. So let this be our triangle, and let's make a line here. Okay. Now what we have to find is this sine of A and sec of A. So let's come here. Let's zoom in. Great. So let's start with, so we have to find two things. One is sine of A, and then we have to find sec of A. So now since we have the length of all three sides, this becomes quite simple thing to do. So sine of A, again focus on this angle. This is the angle of our focus. So sine of A is opposite divided by hypotenuse. Okay, so I'm going to directly write it down. It's opposite 15K divided by hypotenuse 17K. That is equal to 15 by 17. That becomes the value of sine of A. And sec of A is in fact 1 upon cos A. And so it's a derived function. So sec of A is equal to 1 upon cos A. And what is 1 upon cos A? It is equal to, so cos A is adjacent side, just to make a note, that's equal to adjacent side of angle A, and this will be hypotenuse. That becomes our definition of sec A. So remember, these trigonometric ratios are derived trigonometric ratios. So you need not remember the direct definition of sec A. You can always convert this derived trigonometric ratio in the standard trigonometric ratio for cos of A or sine of A. Sine A and cos A, these are the two standard foundational basic trigonometric ratio. So once you convert them into this form, and then you have to just remember their definition. Okay, so our sec A is equal to hypotenuse divided by adjacent side of angle A. and okay, so that is equal to, our hypotenuse is AC, the whole divided by adjacent side of A is AB, but AC is equal to 17K and AB is equal to 8K, and that is equal to 17 by 8. So this becomes our value of sec of A, and this becomes our value of sine of A.